Household water usage story. Here I have the scatter plot with the squares of the residuals and the best line of fit. Here I have the scatter plot with the squares of the residuals for the least square regression line. Similarities and differences in the squares of the residuals. Similarities. Both lines show distinct squares that range from the data. In both models, the smaller the square, the closer it is to the average of the data. The larger the square, the more of an outlier and farther away from the data. Differences. There is a slight difference within the regression line. The squares tended to be a little bit more smaller because data was closer to the average. Number of gallons compared to least square regression line model. The number of my gallons was 266.56 gallons, but the least square regression line was 84.5 gallons. In the comparison, I said, my personal household use of water is much larger than the least square regression line. This means the regression line is not reasonable in the way of living for an average person. It might not take into account the amount of people living in the space. Statements made. The first statement I can make about both gallons and amounts of people in the household is that less people in the household, which ranges from 0 to 2, the less gallons used, which ranges from 0 to 500 gallons. The most gallons used in a household are with people with the amounts from 2 to 6 in a household. This is where the most data stood. With amounts of people 6 to 10, which are fairly large groups of people in a household, data tended to carry out and outliers were expected. R squared and the LSRL fit and how it fits the data. The R squared is 0.202. This is a weak correlation because the closer to 0 means weaker and then the closer to 1 means stronger. From the weak correlation, it can be inferred that the least square regression line does not fit well to the data. The line is not placed in a space where the correlation can be represented for most of the data and be strong. This can also mean that the squares, or the residual squares, were fairly larger since they were not closer to the average of the data. Water usage in your household compared. This means the water usage in my household varies compared to the rest of the class. Having 2 people total in my household means a smaller amount of water usage is expected. Others also have smaller households, while the majority of the class will have a larger amount of people with more gallons used. Compared to school, I believe it would vary a little less because more data means more chance for similarity. Along with comparing across the city, there is a chance to have more similarities, but I also added the fact that there is more chance for variability because of stronger outliers with more people. Estimation for Antelope. I would estimate the city of Antelope uses millions of gallons per day due to the amount of people and the amount of ways to use water. I would estimate 20 to 30 million per week depending on the weather or the circumstances, which could be droughts. Per year, I would estimate close to 1 trillion gallons or a little less because of the amount of days in a year and the amount of people in a population. Within the linear model, which is representation per day of gallons used, the average is a couple hundred per household. Now, multiplying a couple hundred gallons with the antelope population is a little over 1 million. Which estimation? I believe my estimation of gallons per day for the population of antelope is the most accurate because it is a smaller, more distinct prediction. When it gets to months or years, the data gets a little bit more unpredictable and the possibility for error grows. Is relationship between city population and the city's residential water usage causal? Analysis of the graph. The relationship between population and city water usage is causal because besides the minimal amount of outliers, as population grows, water usage also grows. The more people entering a city, the more amounts of water that will be used. In terms of the outliers, this could have occurred due to unknown variables, including a need for water and landscaping. It could also include conditions and droughts. Analysis Part 2. The graph most helpful in highlighting the relationship is scatter plot because the points clearly indicate the amounts of water used. Placed easily at the amount of population, that creates a visual that's pretty easy to trace. The correlation is moderately strong, although both factors grow with each other. A small amount of outliers stop the relationship from being super strong. In order for the relationship to be causal, one factor has to be proven to cause another. It is stating the fact that the amount of water population in a city affects the amount of city water usage, which we can see a gradual increase when one is added. Analysis Part 3. Another variable that can affect water usage is the conditions of the area. Ranging from weather to drought status, this will determine how citizens use their water provided. They can be causal. One example is if there is a drought, people will limit their water and save it. Looking at other variables might change on the relationship because population and water usage, or between population and water usage, because it can explain the outliers and show me the trends and that in what influences the increases and the decreases in both factors. Some data that is needed is the condition of the city during that census. It would help to strengthen my case because it would provide specifics and would possibly provide explanation for outliers. And thank you. That is all.